Uh, Bismillah Rahman Bismillah Rahman Rahim. So we start the presentation with the this topic epistemology, which is a continuation of the previous presentation. So we just talked about epistemology in the previous presentation and slides as well. That is what the way in which you choose to investigate the world. It's up to you how you want to investigate the world, which facts are actually you reveal, and how you will find out about the those facts. So two main schools are there as well in epistemology, that is called positivism and social constructivism. The positivist approach believes that the best way is to investigate the world is through objective method such as observations. Positivism fits within a realist ontology. As we talked about the four various kinds of ontologies, the first one is the realist ontology, and obviously there we believe in experiments. We need exactly how the facts will work, and we have the understanding of what is the reality in the given mini world. So positivist approach always believes to investigate through object methods. So you apply a certain object approach, and then you believe that okay, that is true in your given world, or that is false in given world. So you have to investigate in your own manner. Let's suppose you just talked about finding out the images, various DICOM images or MRI, CT scan images of, for example, lungs, or various views of lungs. So what you want to do, you apply a certain method to see what are the deformations which are there within those images. What is the difference between one image to the other image, and how you define those images. So again, that is an objective method. So normally in the positivist approach, we always go for the objective methods, and normally that positivism approach basically lies within that realist ontology. The second one is called social constructionist. By the way, when we talk about computing research, or when we talk about research in the domain of computer science, normally we go for the positivist approach in terms of epistemology. Uh, Social constructionists believe that reality does not exist by itself. So there is there is a school of thought that believes that reality is not there. Instead, it is constructed and given meaning by people. They believe that actual reality people don't know about it. For example, there are people who still believe that we don't know exactly how that sun works, how that energy is being generated from the sun, and how that energy is being conserved. So there is a belief, still a belief, that we do not have the create reality of that particular concept. There is still belief that people about brain, although the scientific method revealed that how what are the parts of the brains, and they also revealed that what are the functions of the brain, but still there is there is a concept that we have some sort of limited knowledge, and still there are certain things which even cannot be identified clearly in terms of functioning. So that basically is the approach that is called the social constructionist approach. Their focus is therefore on feelings and beliefs and thoughts. So normally whenever they go for research side, they try to find out those feelings and beliefs about that particular fact, how people see about it. For example, let's suppose we don't have the exact knowledge about how online teaching actually is effective compared to the classroom teaching. So still people have different ideas. Some people say it works very well. Sometimes students say it works really well for us because we have those recorded lectures available with ourselves, and we can repeatedly see those lectures. So whatever happens in the classroom, that is just a 1 hour or 2 hour session, and that finishes. So we have to write everything. So there we have that time. So there are various beliefs about a particular system. So there you have to understand how people understand it. Let's suppose I just gave you the example of vaccination. So there are lots of different point of views which exist in the minds of the people, and lot of people normally say, okay, they do not go for vaccination. They have some sort of a fear, or they have some facts in their minds which are not true, or they heard something which confuses them. So they have different beliefs. So if you go for finding out why they are not doing it, if you talk to various people, you take a population size and take out some sample and go through and find out what is their feeling and beliefs and thoughts about vaccination, you might have a very interesting results. And you can see that how the people are responding in Pakistan, obviously, which is totally different from the people who might be responding in North America, or the people who might be responding in Italy and China. So what is the feeling about? Let's suppose you talked about cloud systems. So a lot of enterprises here in Pakistan also adapted the cloud technology, and initially there was reluctance, but even now in public sector organizations, they go for cloud-based systems. So now you want to see that how people have actually they have a belief, or they have a feeling about such systems. Do they think that they are secure, they think that their data is always available, or they think all those services will be they will be receiving all the time, or whatever the. So there you have to try to find out that knowledge from those people. So that is why the social constructionism fits better with the relativist ontology, as we have discussed earlier on. So epistemology and ontology will have implications for your methodology. So if you do not have idea about ontology and epistemology, you cannot jump into methodology. So come out with some philosophical point of view. So normally students do not have any background of philosophical knowledge. They just start talking about the problem, and they just start talking about the data. This is a wrong approach. You must have a clear, spend some time, try to find out. You must have some basic concepts. So if you don't have those basic concepts, you cannot explain your problem. So realist tends to have positive approach, as we discussed in the previous slide as well. So tend to gather quantitative sources of data. Now you have that understanding that those those who believe in the realist ontology, they have a positivist approach when you talk about epistemology. And when they have that positivist approach, they go for the objective analysis. And when they go for the objective analysis, they normally go for the quantitative sources of data. They want to apply some quantitative analysis techniques to see that how it works. In comparison, the relativist tends to have a social constructionist approach, or it means that they tend to gather qualitative sources of data to see how people have a belief in it, to see that let's suppose the various experts might have different point of view. So they look for a particular subject, and to see that how they believe about a certain fact. So they have to interact with the people. Let's suppose to have some sort of, let's suppose to use some sort of unstructured interviews, or to gather that information and to link their point of view, or whatever the hypothesis you have built to the idea which is being generated by various people. So remember, these are not absolutes, as we have discussed earlier on. People tend to work on a continuum. We go and working. It's a continuum. So role for mixed methods approaches. So there is not a fixed criteria that either you are quantitative side or either you are on the qualitative side. So it is even the mix of those, that is called a mixed method approach. So there, in a mixed method approach, we have in the objectivity, we are realist as well, we collect the data, but so we are not sure about the outputs. So what we do, so we have to have some qualitative analysis as well. We show our result to the experts and see how they respond to it. We add their input into it and see how your model actually whatever the quantitative finding is, what whether those experts, let's suppose, have the have an agreement with what the results you obtained. So it means that you can mix the approach as well. You can apply some statistical methods even to for the for the quantifiable data, but you may use, for example, focus group discussions. You may use some interviews and for collection of qualitative information, and then you interconnect both qualitative and quantitative information to see that whatever the hypothesis which you have built is true or false, whether you can support your hypothesis, or you think that whatever the research you have done is proof that your hypothesis is not true with the given evidence. So the role of researcher is, of course, is there, which is very important, and obviously that has to be in line with the supervisor. A quantitative data is about quantitative and therefore numbers. So whenever we talk about quantitative side, we always talk about numbers. So we believe in numbers. We always play in numbers. We are interested to know how many images we have, what type of image data sets we have, what type of pixel data we have, or we are interested to have the data about electrical grid network. So how many grids we have, what type of voltages they are carrying, okay, what are the different levels of grids in that particular network. So we need to have that data all the time. So we are interested in data. We talk about that network analysis. We need to have that data. We need to have interconnections. So we exactly know. Let's suppose if I want to build a network of, let's suppose a network of people who are arrested in any case in Pakistan, and the crime and a certain crime, for example, or the immigrations or illegal immigrations we have in Pakistan. So we want to connect these two things together. So there we need to have that data. We need to have data about those people, what type of crime they have committed, how long they are in the jail, whether they are still in the jail, whether they are convicted, they are not convicted, whether the FIR is being launched or not, which nationality they belong to, where they live, so on and so forth. So we deal with the data all the time. So any problem, if talk about a quantitative data analysis, obviously, then we have to play in numbers. Qualitative data is about the nature of things investigated and tend toward rather than numbers. So here, numbers are not important. The viewpoints are important. Even there is only a one viewpoint which is against, but sometimes that viewpoint is very important, and you cannot neglect it, because there you will not go for the numbers. You have to see that what type of for example, the reply we have about a certain model. Let's suppose we have developed a model and then a quantitative model, and we applied to the problem. But maybe some of the experts which of the field might say that although your model works well, but realistically it is not applicable because there are other factors which you have not considered in the model. So that only fits somewhere, but in many cases it will not fit. So the qualitative data analysis, when we talk about qualitative study, that is very important to understand what are the themes. Normally we go for thematic analysis. When we talk about qualitative data analysis, we go for expert opinions. So those opinions are very important when we talk about qualitative data analysis. So difference between the primary and secondary data sources, which we have discussed earlier on, said the data which you generate yourself or the data which you might have available on reliable sources. Remember, I'm talking about reliable sources. Never use data which is not reliable, or data which is not a quality data. When I say a data is not a quality data, it means a data is inconsistent, or data is incomplete or insufficient, or it is being gathered from the source which we don't know. We cannot use that data in our research. That is not acceptable. Either if you want to publish something in some reputable journals, they also investigate what type of data you have and how you have generated that data. That is very important. So always believe or always search for good resources or reliable sources or quality resources of data. and verify it. Just do not just do not rely on just web pages and try to find a link and download the file. No, downloading a file or from a web resource does not mean it's reliable. You have to recheck it, you have to verify it, because you are using it to build your hypothesis. You are using it for confirming your belief, or let's suppose confirming your hypothesis or a problem statement. So if you are not working on the finding out the reliable source, then whatever the analysis you will done may be rejected, may not be accepted, even at your MPhil and PhD level, or even in publication in reputable journals. Remember, I always focus you people on publication in journals which are reputable. Please, because you are going through with your MPhil phase and PhD phase now. So please always consider reputable journals and conferences. Do not waste your papers in conferences and journals which do not have any recognition, because it's a wastage of your time. Some students are in a hurry, they just want to publish something and they want some quick results for their short term gains. That is wasting of your data, wasting of your efforts. So do not go for in a hurry and publish something. Always take your time, work well, and try to publish in good journals. And wherever you publish, let's suppose in good journals or reputable journals, they always see your research methodology very carefully. The reviewers will see the research. They might ask you for review, they might ask you for some questions, they raise questions about your research, and you must be able to respond them. So in a research, whenever we are doing something, we must have that knowledge to respond, because whatever you are presenting is from your side. So you have to respond to all those queries which have been generated by reviewers. So be aware of research data management practices and archives of data sets, both in terms of downloading and uploading. As I told you earlier, that you have to be very careful while you are using any such resources. Choosing your approach. So your approach may be influenced by your colleagues' views, your organization approach, your supervisor benefits, beliefs, and your own experience. This I have discussed also in the previous presentation, that you always influence from somebody, maybe from your work, maybe work from your friends, from your supervisor, so on and so forth. So there is no right or wrong answer to choosing your research methods. So whatever the approach you choose for your research, you need to consider 5 questions. Number one, what is the unit of analysis? For example, country, company, or individual. So unit of analysis, you have to determine, okay, you are collecting the data. So either you are collecting the data about an individual company or individuals, or you need a data about a country. Let's suppose I just gave you an example of electric grid network of Pakistan. So you want to have that data, or you want to have the data of, for example, the mobile network system, with whatever works over here. So you want to see that how that mobile connectivity works. So what is the unit of analysis? What type of data is required? Or either you are looking for some sort of universal data. Maybe there are data which is involved various countries. Let's suppose you want to do some sort of computing based research on coronavirus spread out among the countries, various countries or various regions in the whole world. So you have to determine the unit of analysis. So that has to be decided in consultation with your supervisor, that what will be unit of analysis. It cannot be very small. Let's suppose if you are doing your PhD research work and your unit of analysis is very small, then it means it might be unacceptable. So you have to see that what will be your unit of analysis. Are you relying on universal theory or local knowledge? That is, will your results be generalizable? Can you generalize your results? And you can come out with some universal applicable results which are applicable everywhere. For example, you have developed, or you have proposed an algorithm to early detection of carcinoma in lungs. So if you are able to do it, whether that model can be applied anywhere, whether the results can be generalized, because in some researches we can generalize the results, and if the results are generalized, that research can be used anywhere. And obviously that has more you can say viewership, and the people might be interested in that. So but by doing so you have to be very careful, because if you are generalizing the results, then you must have the global scenario with yourself, or their local factor that will affect your results. Or you can say that that model, whatever the model you propose, might fit in a certain view, in a certain local view, and you have solved, let's suppose, a problem in a certain local view environment, or in a local view where you cannot say that it can be generalized. However, you can say that that study might be conducted somewhere else to find out what type of output they might generate. So it means it is not generalizable. So that is based on the local knowledge. So we talked about the coronavirus spread out all over the world. Let's suppose you are only interested to know how the coronavirus spread it over in various regions of Pakistan since the last February 2020. So here you just rely on the local knowledge. So that's up to you. Whenever you go for your research study, you have to identify what type of knowledge you will rely on. Will theory or data come first? Should you read the literature first and then develop your theory, or will you gather your data and develop your theory from that? So there are two ways, vice versa. Some people they start working on the data and then then build the concept. And the other thing which normally I work on, I believe in literature review. So whatever the topic which you consider, or whatever the topic you have decided, or whatever the problem statement you might have in your mind, first go for the literature review. It is very important, because whatever we think or whatever we decide, sometimes we are or we have some, you can say, limitations, and we think something in our own point of view, but you do not have the idea what have been done already. You start working on some security algorithms for cloud computing environments, but let's suppose you must have the idea that what are the other security algorithms which have been proposed over a period of time, last 5 6 7 years, and how they are being used. So is there any problem or in those algorithms, or there is something which is not being addressed, and you think that that has to be proposed, or that is important and relevant, and that has to be addressed. So you come out with your idea. So this is only possible when you go for the literature review. So without literature review, it is not possible. Will you? But if you go for research and you get experience in research, then the other approach will overtake, and then you will be able to have that data with yourself, and then you build theory from it. So you can do this, but I believe with experience. So I did a lot of research for the last 15 20 years, but now I believe that sometimes I consider the data first and then try to develop those concepts. So it's up to you. But for the beginners, I always believe that you go for the literature review first. Will you study the cross sectional or longitudinal? That is the other question which you have to ask yourself, that whether your research study is a cross sectional, are you looking at one point in time, or changes over time? So if it is changes over time, it means you're talking about longitudinal study. Okay? Or you are looking for one point in time, that is called cross sectional. So you decide yourself whether you go for the cross sectional study or it's a longitudinal study. Sometimes we're interested to know how data changes over a time. That is normally we do a lot of data science approaches. We see, like, let's see, we talked about the spreading pattern or spread pattern of coronavirus. So, spreading phenomena, you want to discover what is the spreading phenomena of the coronavirus in various regions of the world. So, there obviously that happens over changes in time. So, it's a longitudinal sort of study. But if you are interested in cross sectional, let's suppose you pick one period, let's suppose maybe the July 2020, and you want to see that how in July 2020 in Pakistan the coronavirus spread out, and how in July 2020 the same thing happened in India. So you want to compare these two things. That is cross sectional. So will you verify or falsify a theory? So the last thing which is important is that how at the end of your research what you will do. So you are either prove or disprove. That is the two things which are possible. Either you prove your theory or you disprove your concept or a theory. So you cannot conclusively prove any theory. The best that you can do is to find nothing that disprove it. But you sometimes you do not have a complete evidence to prove it, but you do not have a sufficient evidence even to disprove it. So it is therefore easier to formulate a theory that you can try to formulate a theory that you can try to disprove, because you only need one wrong answer to do so. So if you are able to prove it that this is wrong, then it is easier for you to explain your point of view, or or it is easier to explain that you have achieved something. So that is the various viewpoints you have, or various you can say approaches we have. So whenever you go for a certain approach, you have to consider these five questions very important. Quantitative approaches always attempts to explain phenomena by collecting and analyzing numerical data. That is clear. We have discussed this earlier on. I know there is no need to explain it. Tell you if there is difference, but not necessarily why. Data collected are always numerical and analyzed using statistical methods. It can be statistical methods, it can be mathematical methods, it can be graph-based techniques, it can be anything which you can say. But normally we go for statistical techniques. So variables are controlled as much as possible, so we can eliminate interference and measure the effect of any change. So variables are very important. We have discussed these variables in our previous lectures, that what are those variables, and we talked about the dependent variables and the independent variables as well. So variables have to be controlled as much as possible, because whenever we go for a research study, we need to consider on certain variables. We need to know what are our dependent variable and what are our independent variables. So we have to build those relationships. So we need to have a control on those variables. And obviously we are interested in the effect or change, if something happening, so how that variable will change. Randomization to reduce subjective bias. So always when you go for your research, randomization is a very important aspect. You always be random, so that you can reduce the subjective bias. Otherwise you will opt for certain subjects which has certain characteristics, and you easily prove it. But this is biasness. Let's suppose if you want to study the impact of vaccination on people, and you just take a few instances who already have some serious diseases, and then you prove that okay, vaccination has this impact on the people. Or you can in another way, you want to study, for example, from computational point of view, that the patients who are having corona and with having certain diseases have a less chance to survive. So there you pick subjects according to your own purpose, and then you try to prove, see what I say, this is happening. So this is not a good idea. So you always go for randomization, and you go for random sampling, and there are various random sampling techniques which are there. You have to pick out those according to the problem. If there are no numbers involved, it's not quantitative. Then it means that there is opinion which is there rather than numbers. So those opinions are not always considered in terms of numbers. So every opinion and point of view is also important. Some type of research lend themselves better to quantitative approaches than the others. So it all depends upon the problem you have. The quantitative data sources include surveys where there are large number of respondents, especially when you have use a Likert scale. Likert scales are normally there where you have those responses. Those responses might be 3, 5, 7. Normally, these responses are in odd numbers, 5, 7, 9, and there are some responses which is on the one side, on the extreme side, and obviously there are responses which are on the other extreme, and there are some responses where you think that the people do not have any idea. So normally we have responses in a manner that strongly disagree, agree, don't know, or no idea, agree, strongly agree. So this is sort of a Likert scale we have. So normally in some cases we go for survey study. For example, you want to have a research title that you want, or you want to have a research top in your research topic. Let's suppose that you want to see that whether the organizations in Pakistan, they are those who are using the cloud computing techniques or cloud computing methods or approaches or cloud services. What you want to study the acceptance level. So what you do, you apply, for example, the acceptance model, and you want to survey those organizations and to have that input from those organizations, and then you apply it for. Similarly, you want to have a survey of the people who have been diagnosed with the coronavirus. So, what is their point of view? Or you have to have a survey of healthcare workers who have been working for the last year or so in hospitals, and they are dealing with the corona patient. So, what type of fears they might have? What is the psychological impact on those people, healthcare workers? And you want to analyze this with the help of survey. The second thing is observation, which is very important. You observe and you count. You observe and you code. So you have various observations with yourself, and you are, according to those observations, you put that data, and you can use that data. And then obviously the secondary data you have, from where you can have that data from the government sites, from the institutions, from the international bodies or reliable bodies, and you can have that data and you can use for research. So there is secondary sources data, which is globally available. So it is there for everyone. So you can download and use it. But there are other resources as well where that you have to take the permission. Without permission, you cannot use that data. So because if you do this, it is go in, for example, unethical practices. So always remember that you have to go for ethical practices, and you use ethical practices. So analysis techniques include hypothesis testing, correlations, cluster analysis. These are few. Maybe the regression analysis, network analysis, graph analysis, probabilistic modeling. There are so many things. Probabilistic approaches. You can apply various techniques. You might use uh, evolutionary algorithms and so many other things where we are. So for falsibility or refutability, when we talk about falsibility or refutability of a statement or hypothesis, when I say refute, it means it is false. Or normally we call it falsibility or refutability of a statement, hypothesis, or theory, is the inherent possibility that it can be proven false. So, whatever the theory which you will think about, there is quite a possibility that it can be proven false. So call paper and the black swan, detective CF, inductive reasoning. So we have various kinds of reasoning, as you know, in logic. So today we do not have a topic of reasoning. We will have that session later on. So deductive versus inductive reasoning. So both approaches are there. So we go for hypothesis testing, start with the null hypothesis. Then normally we represent this H naught. And what we say, null hypothesis what? That there will be no difference. And then we will prove that this is wrong. So it means that there is a difference. So the alternative hypothesis will get true. So wherever we have H naught, we have H1, H2, and so on. So there are various kinds of errors which are related to it. So whenever we do so, we have errors. That those are termed as type 1 and type 2 errors. Just remember that the boy who carried wolf calls, both type 1 and type 2 are in order. That is the example which has been discussed in one of the paper. So first everyone believed that there was a wolf when there wasn't. So they thought there was a wolf. Next day, they believed that there was no wolf. Then there was. That was a story related to an individual who always come and say there is a wolf, there is a wolf, and people go there and there is no wolf. And one time he cried, "There is a wolf, there is a wolf," and the people said, "No, will not go there. There is no wolf." And actually, there was a wolf. So something happened. So substitute a fact for wolf, and you are done. So that is type one and type two error. So analyzing the quantitative data, always good to group or visualize the data initially, and you can average, you can use statistical means, spreading of data, you can check how the data is being skewed, whether left, right, or centrally skewed, what is the standard deviations and variation. These are the basic things we have. um, what are you looking for? Trying to find a signal from the noise. Yes, we might look for this. Difference between two groups, use correlations. You can use for parametric and non-parametric text, depends upon what sort of data you have. Whether data is available in intervals or the data is available in ratios. Correlation does not imply causation, obviously, and you can see the example correlations drawn by falling into a pool, and that is number of people who died by becoming tangled in their bed sheets. वो ज़्यादा हैं इसके मुकाबले में. By the way, so you have various interpretations of the data, and you can, according to those interpretations, you might represent that data. So interpreting the testing high statistics, where you have the significance level, and there you have the p-value, the probability of getting the value test statistics हम कैलकुलेट करते हैं. That is called power ability to detect a difference if there is no if there is a one. Effect size, numerical way of expressing the strength or magnitude of a reported relationship, be it causal or not. So significance level, normally we have a 0.05 or 0.01 level पे significance पे normally we check. Example of quantitative data analysis may what we have the null hypothesis. Let's suppose H naught, there is no statistically significant difference. H1 is the student who learn in a matched environment will learn significantly better than those who are mismatched environment. You have to prove it either. Or H2, you want to prove students who learn in a mismatched environment will learn significantly worse than those who learn in the matched environment. So there are different H0 and H1. So that in that manner we calculate these things. So there is no need to explain the interpretations right now here. So I just conclude over here. What quantitative researchers worry about is my sample size big enough? That is important. So if you want to make a statement or you want to prove or disprove yourself, your sample size must be enough. And that is that I will discuss in the sampling lecture. So we have a separate lecture for the data sampling. So there we will see what type of size is required. Have I used the correct statistical test? Maybe you cannot apply the NOVA test and you apply the NOVA. You cannot apply the t-test. T-test is not recommendable at that point. You apply the t-test and you are interpreting the result. So you have not used the correct test. So your interpretation will always be wrong. Have I reduced the likelihood of making type 1 and type 2 error? Or there is more likelihood? Are my results generalizable? Can I make it generalized, or it's only for the localized knowledge? Are my results reproducible? Can I reproduce these results and use these results for other problems? Am I measuring the things in the right way? That is the key questions whenever you have that quantitative data with yourself. Your metrics should be correct. If your metrics are wrong, then you will lead to a wrong results. So some things can't be measured or measured accurately. Doesn't tell you why. Can be impersonal, no engagement with human behaviors or individual data, can be static, or you might have some snapshots at a given point in time. Can tell a version of the truth or a lie. Lies demand lies and statistics. Persuasive power of numbers. So from numbers you can do anything. You can persuade anybody. Although you have some snapshots of the data with yourself. So you cannot exactly measure everything, and you have to come out with your own findings in the quantitative approach. So with this, I conclude over here the lecture, and I hope that you understood the lecture, and you will use that knowledge actually whenever you are conducting your research. Thank you so much.